Hello, hello, welcome back to the channel. Today we are dealing with PlayStation 4, which came in for not powering on. And the customer actually told us that stopped working, and when he tried to connect it again to the power, it blows the fuse. So it's completely dead. So I have disassembled the PlayStation 4 board. And he actually told me that this specific PlayStation 4 has been brought to another repair shop 7 months ago, and they fixed something on the main PCB board. It worked for 7 months and stopped working. So the first thing I did when before I disassembled the board was to check actually if the power supply is shorted. So I checked with the multimeter in ohms mode. Here is the PCB board of the power supply. I have just removed it completely out of the PlayStation box. So I actually measured on the input of the AC and it's completely open. So the fuse is blown. So if you measure the fuse here, it's 0. If you see on the multimeter, it's open line. So the fuse is blown, it's gone. And the next thing I did was actually measure the bridge rectifier, which is here. This is the main bulk capacitor, which is actually has no voltage right now. If you measure the bulk capacitor, it's 0, nothing. So here is the bridge rectifier. So if we measure in diode mode the bridge rectifier, these are the 4 legs. These are the plus, minus, and the middle ones are the AC line. So if we measure from the plus with the red probe to the inside of the AC, we hear a beep, so it's shorted. This diode is shorted. Also, this one is shorted. But if we measure on the other side, it's okay. And on the outside, plus, minus, it's okay. So there is something wrong with the bridge rectifier. We don't know yet. We have to remove the bridge rectifier in order to be able to measure it outside of the PCB board to be sure. Also, there is a diode here, which is actually, this diode is actually on the EFC circuit. We see here a MOSFET and a diode, a resistor, and another a resistor here, and a diode. So this MOSFET here is actually the main MOSFET of the PFC circuit, and the diode is in series with the coil of the PFC. So this is the power factor correction circuit. So if we measure this diode, let's see, it's shorted also. So there is a problem either with the PFC circuit or the bridge rectifier itself, or there is another problem on the secondary. We're gonna see. So let's start by removing the bridge rectifier, which is here. Okay, so we're gonna use the soldering gun, which is not plugged. Give me a second. All right. I'm gonna use some rosin flux to make the solder joints softer, and some soldering wick. All right. This will absorb the soldering. Help us remove it completely out of the PCB board. This part is gone. A little bit of rosin will help here. Yes. Gone. Little bit of rosin. Gone here also. Right, I think we can remove it now if we press it gently. Yes. And the bridge rectifier is off. So this is the bridge rectifier. The model number is GBU608. Alright, so let's measure it. Diode mode. All bridge rectifiers, this type of bridge rectifiers, have this curved edge. This is always the plus. And the other, on the other side, it's the minus. And the middle ones are the AC lines. So if we measure with the red probe from the inside of the AC to the plus, we hear a beep, so this bridge rectifier is gone. Also gone, but the other parts are okay. So this part of the diode inside the bridge rectifier is gone. So we have to replace this. Okay, this is gone. Let's check the other diode here, which was measuring short. Let's see. It's also shorted. Okay, so let's investigate further about this. So this diode is here, here and here. So let's remove this diode also. All right, I don't see the marking of the plus and minus, but we can figure it out from the PCB board. Yes, so let's see. If we go to beeping mode, so this part of the diode here is this part, which connects. So this one is the, no. So this part of the diode goes to the resistor, which is this one. This part connects to this. So this connects to this, and this goes to the plus of the capacitor. So this is the plus side, and this is the minus. All right. Okay, so let's remove the diode. I'm gonna cut this wick which is used and use the clean part. Also turn off the multimeter to save some battery. Use rosin flux to soften the solder here and here. Okay, good, good. This is a powerful 100 watts Weller soldering pistol. It's an old one. I've been using this for. This was actually my father's. He had a repair shop 30 years ago, and it's still working. I made some repairs on the pistol scandal here, but apart from that, this is a really powerful, and I only use it when I want to desolder this kind of joints, which are really hard to desolder. So with a small soldering station, you cannot easily do that. So let's bend this, this, okay. All right, so let's measure this diode. Diode mode. This is gone. This is gone. So let's see if we can read the part number of this diode. I think it's impossible to read. There's nothing written, actually. Let's see with the microscope. Let's switch to the microscope. Read anything. There's nothing. No markings, nothing. What kind of diode is this? Nothing. So let's see if we have more faults on the PCB board. Right. Okay, so here is the place we remove the diode. Right, so let's measure this MOSFET here, diode mode, to see if we have solved the problem. Right. Okay, seems okay. This diode here, open the other way. Okay, 0.4 voltage drop. And this FET here, open. This, open. Let's do it the other way around. That's the probes correctly. All right. Nice. So this is okay. What about the output? It is this probe, these metal probes here. voltage drop 0. No, not with diode mode. Let's measure in ohms mode. On the output we have 5.4 mega ohms. 3 point is dropping 2.8 mega ohms, so it's okay. All right. So I think we should replace the bridge rectifier, replace the fuse, replace this diode, and we should be okay. We will test this power supply with series lamp connected to see if we have any short. And I think this is fixed. Let's do the replacements and I'll be back again. Okay, okay. I came back. I found an old PCB board from a power supply of a computer power supply, which is I have a lot of them, lots of them for parts. So I will use this bridge rectifier from here, and also I will remove this diode from here, which is from the same circuit, the PFC circuit, and I think we're gonna be okay with this. All right. So let's do it. The same procedure, rosin flux, some soldering wick. The bridge rectifier is here, and it's been held with this heatsink, which is solder with these two big legs here, here and here. All right, so let's remove it. Try to remove it. All right. Rosin flux first to soften this 10-year-old solder. Okay, so let's use the wick now to absorb as much of the excess solder we can. This is gone. This is gone. Soldering wick stuck on the PCB board. Let's use some flux. Okay, this is gone. Let's cut the wick. Use some fresh one. Okay. Okay. This side is okay. This side, okay. Okay. On this side, gone. All right. So let's try to push it gently. Now we have a lot of work to do. We might need to put some fresh solder, some leaded solder, in order to soften the joints more and desolder it again. We'll see. This part is really tricky here. All right. A bit more here. this leg. Yeah, we forgot this leg. Oh, this heatsink. Let's soft the old solder paste first. Yeah, and try to absorb it with a wick. That's the procedure. That's it. Let's press it now. Yep, yep. And it's gone. That's the bridge rectifier. And we also need to remove this diode here. This is, I think this will do, yeah. Let's put a bigger one. Oh, let's remove this one. But I think I already have some diodes. Let me check before I desolder. Yes, I have some diodes here. So we will use one of these. This is from a bridge rectifier I was building. So this should be okay. Let's desolder this. Yep. All right. And of course, we're going to test them before we use them. So let's see. Multimeter in diode mode. So let's first test the bridge rectifier. So you see here, we have this edge, which is the plus. And if you see on the marking, I don't know if it's visible on the screen. This edge is plus, and this edge is minus. Okay. And the middle ones are the AC lines. So let's go with the red probe on AC line. On the right, it's okay. The other one, it's okay. On the edges, we see both the diodes, are reading 0.9 voltage drop. And let's see the other side. It's okay. And this side, it's okay. So the bridge rectifier is okay. Let's test this diode. This diode, the black probe on the marking of the cathode and the other one on the anode. And it's okay. It's reading 0.5 voltage drop. So it's okay. This is a normal classic silicon diode. It's not a Schottky one. We would read about 0.1 or 0.2 voltage drop if it was a Schottky diode. This is a normal silicon diode, 0.5 volts voltage drop. And on the other side, we should read open line. If we reverse the leads, nothing, open line. So we are okay. So both these components are okay. We should replace them. All right. So let's see how we're going to put this. Should we keep the heatsink or not? Make an improvement on the power supply. The original one didn't have any. So we can cut these legs and solder with the heatsink on board. So let's see if we can do it. But first we need to clean a little bit here in order for the bridge rectifier legs to be able to pass easily through the holes. Yes, that's nice. So if we remove these legs, we're gonna cut them flat. Come on, all right. So if you see the PCB board here, there is a marking with the edge, so you can see how the bridge rectifier should be installed. So the correct way is this way. There is a capacitor here, it blocks a little bit. Let's try. Yep, it's installed and it's okay. Let's try to solder it. This time we're gonna use, let's use this, it's the same. Nice. Bridge rectifier is soldered nicely on board. All right. Now the diode. All right. So the diode, the plus is here. Plus is here. Let's clean this. Some more cleaning here. Let's do it with a soldering bit. All right. The legs are clean now. Nice. Here are the legs. Let's be sure. So it's the other way around. The plus is here. Let's solder it. Problem is that I have to hold with one hand and solder with the other. Let's do it. Right? Nice. 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 All right. And final step, we have to replace this fuse, which is blown. Let's remove it. The fuse is here. Clean the solder. Some rosin. Soften the joints. More. Right. Gone. Gone. The fuse is gone. All right. This is the fuse, which is, let's see what it says on the microscope. It's a 4-amp fuse. All right. Great. Great, Scott. So I have to find the fuse. I just replaced the fuse with a new one here. I also replaced the diode which I replaced previously with a bigger one, because this the previous one I used was a small one that could not handle a lot of volts, so I replaced it with a bigger one to be sure that it's not gonna blow again. And also the bridge rectifier, I think it's okay with the heatsink, and it's an improvement to this power supply. So we are actually ready to test this. Okay, here is the power connector of the PlayStation 4. Actually, it's the standby that it triggers the power supply to turn on. So we have some standby voltages here, 5 volts standby, so we can check here if it's working. But before we connect this to the AC, we should connect it first to a series lamp, so to be sure there's no more shorts on the board. So here I have a test equipment. I will make another video of how to build such a device. This device actually is a series lamp with the AC line, so we can see if there is a short circuit on the high voltage area. So here is the main switch, which turns on and off the main, and here we can bypass the lamp. We use normal high wattage lamps, so we can test the circuit. I have installed 2 switches here. I do not use a second lamp because I don't have one. I use only 100 watts lamp here, and I can put another one on this position. So the first switch here is lamp on. It has to be in this position. If you press here, it says bypass, so it bypasses the lamp and passes the current directly to the wires. But if we have it in that position, this controls the current and passes it through the lamp. And this is always bypassed because I don't have a lamp, so we need to close the circuit in order to work. So be very careful how you treat this kind of devices, because there is a high voltage here and there is a risk of death. So be careful. So we connect the terminals to the power line here with some crocodile jacks. This is silicon, so we don't have a conductivity here, so it's okay. And now we connect, we have the main switch off, and now we connect the power line to this box. So let's turn the circuit, and we see the lamp just lit a little bit, so that indicates that it's okay. So let's measure. Let me put it this way so you can see. All right, so we've put this to AC voltage, so let's measure to the mains here. And we have 223 volts AC in this line. Let's measure the bulk capacitor, the large one. Let's see, this is the bulk capacitor here. And we have 305 volts there, which is stable. It fluctuates a little bit. Okay. And let's check on the main transistor of the PFC, which is, this is the diode, and this is the transistor here. Sorry, here. No. Yeah, here. Let's see. My wrong transistor is, yeah, here is the diode, and the transistor is here, I think. Yes, 300 volts. So we are okay. And now we are on DC range, so let's check on the output. This is the safe side, so we put the black probe on ground, and let's check on these checkpoints. And we have 4.7 volts here and 4.8 volts here, so the power supply is working as it should be. So I think we are finished with this. Let's turn off the main, so we kill the AC line, and we are ready to install the power supply. But I will show you another problem of the PlayStation 4. So we have to deal with two problems, actually. This was the first one and the toughest one, to fix the power supply. So we actually replaced three components: the bridge rectifier, one small diode. This is from the snubber circuit. It actually controls the returning voltages from the coil, this specific diode, and a simple fuse on the input. That was the problem. Okay, so let me show you now the second problem. The second problem, which will be a part 2 video. This connector actually connects, yeah, this is a huge mistake. I will show you why this is a huge mistake. Even I disconnected the power line from the power supply. If I measure with the DC voltage meter, we still have 183 volts here. So it's not a safe idea, once you unplug the power supply from the main, to just touch it directly, because there are still remaining voltages inside the main bulk capacitor. So check here, we have 164, 46, 42 volts and dropping. So one simple way to discharge this capacitor is not to short the legs of the capacitor, because we're going to cause damage to the capacitor, is to use a very large resistor and short the legs. So if we do it with a soldering gun, we just touch this for a few seconds and the capacitor is discharged. So if we check again with the multimeter, we now have 0 volts. we have minus 2 volts. Okay, so it's okay now to touch it. So let me show you the second problem of the power supply of the PlayStation 4. Excuse me. Okay, I will bring it here. Okay, let's switch to the microscope. And let's check here. Okay. Can you see this broken pad here? Okay. This specific connector, this connector, connects to the power supply here. And this connects to the board. And probably the previous guy brought it to the previous repair shop to fix this, because I can see traces of solder. Let me show you. I can see traces of solder here. So they tried to repair this, and I can see black marks of solder trying to solder this on the board. So what we actually need to do, if you can see, there is a rail coming from here, from this specific point, all the way down here to this broken pad. So we have to run a wire from here to here and connect this connector back to the board, so this connector can get the signal from the power button of the PlayStation to turn on the power supply so the PlayStation can work again. So that's the part 2 video we're gonna do to fix this connector back again to the board. So that was the end of the video. Thank you for watching, and see you in the next one. Bye.